In this tutorial, we are going to see what is the debugger and how to use it in Unity. For this tutorial, I am going to use the Rider IDE, but it's very similar in Visual Studio and other IDEs. So, what is the debugger? The debugger is basically a set of tools that help the programmers to inspect our code and make easier and more effective the process of analyzing it. So, with it, we can spot bugs easily or even discover why the code isn't doing the expected result in the case that we have a bug that isn't affecting the code execution. To know why the debugger is valuable, we need to understand that testing is a different process from debugging. Debugging involves the identification, isolation, and fixation of the bugs. Nobody writes zero-bug code, so debugging is a big part of problem-solving skills, and it should be one of the most important skills of a programmer analysis abilities. It's also very good when we enter in a code base and we don't know how the code flow is working. So the debugger will help us with that, as stepping through the code line by line is the best way to trace the flow of execution. Also, using the debugger could be hard at the beginning, but it's time that we use it to fix a bug. We will probably learn something new that will help us the next time that we need to fix another bug. There are some things that we need to be careful about, because using the debugger is a high time consuming practice, so we should know when to use it and how to use it properly. For example, we shouldn't use the debugger without knowing how the bug happens. So we need to try to identify the reproduction steps so we can debug it in a consistent way. We also should take our time after the bug cause is identified, and we should try to analyze how it can be solved and if it will affect other things in the code. We shouldn't try to do random or hack fixes. Also, even if we change the code and we think everything is fixed and working okay, we should try the game or the code where that code could affect and search for new possible bugs. You might have used debug.log messages in Unity. That's a form of debugging which could be useful sometimes for simple debugging, but generally it's not effective. So now we are going to see some proper debugging techniques and examples on how to use the debugger. Now we are going to see how to use the debugger. As you can see, I have prepared a little script with some examples to see the different debugging tools and everything. But the first thing that we need to do is to attach it to our current Unity execution. So to do that, over here we have this little bug icon that says debug attached to Unity editor. So if we press it, it will attach to the Unity editor and the debugging tools will appear down there. Also in Unity we will have this little window that says that the debugger is attached, but we have to enable the Unity debugger too. So we just have to press the enable debugging for this session. And now everything is ready to start using it. Now that the debugger is attached, we need to be able to stop the execution of our code to inspect the values on it. So to do that, we need to use breakpoints. A breakpoint can be put if you come here between the number of the line and the start of the line. Those points appear over there. So if you click here, the breakpoint will be added. And now, as you can see, this is the start function of a monobehavior script. So this will be executed when we press the play button on Unity. So if we press it, now, as you can see, Unity looks like frozen, but that's because our code is stopped. So now As you can see, some values appear there. We have this gain object, the active scene, and we also have the test variable that we have here. So as you can see, there are some buttons here, but there are 3 over here that are step over, step into, and step out. So if we want to see the code line by line executing, we can start by pressing step over, that is F10 on the keyboard. So if we press it, it will advance to the next line, and this one is just executed. So now the test variable is 0, and on this line we are adding 5 to it. So if we press again, the test variable will be 5, you can also see here. And if we execute the next one, we are going to multiply it by 10, so the test variable will be 50. Now we are calling a function here. So if we press again step over, it will just execute it, but we are not going to see what's happening inside. So to go to this function, we need to press step into. Okay, as you can see, it just jumped here, and now we can also do step over again, or whatever we need inside here. And what if we want to go outside of the function where the code was before? Well, then we can press step out. So all this code is executed, but it just stepped out of it. So now if we press step over again, the start function will end. So that's everything, and then we can resume the program and everything will be running on Unity. As you can see, there are some debug.logs that are from this script over here, for example. So as you can see, all the code just executed because it's called here and here. So this is how you stop the code to inspect it. Now that we know how to stop our code, we can look at some examples on how to use the debugger. So for example, here I have a function where I'm calculating a value. I imagine that is like a very complex algorithm where we are doing a lot of different calculations, and just as you can see here, with those numbers and with those calculations, we are expecting a result of 80, but after doing those calculations, we are getting a value of 72. So imagine that to debug this, we need to put a debug.log on after each of the calculations, and that is not too bad, but because it's very simple. But just imagine that it's a very complex algorithm with a lot of lines, so this is a mess. Okay, so this is why we need to use the debugger, because it's a much more effective way to detect the problem and inspect it much better. So for example, here we are doing x plus x, it's 10 plus 10, so it's going to be 20. Okay, so x is going to get the value of 20. Okay, so now we are going to divide x between y. So this should be 20 between 3. It's something like 6.66666. Okay, so if we press the F10 key, remember F10, step over, as we can see, x is 6, is not 6.6666, and if we multiply it by 12, it's going to give us 72. So as you can see, our problem is over here. And why is that? Because we're dividing an integer with an integer, so it's going to get rid of the decimal part. So as you can see, we just have detected our bug very easily, and we can solve it by changing the value with a float. So now if we just play the game once again, we saw how to fix the bug much more easily than using a lot of different debug.logs. And if we play it again, now it's going to be fixed. So as you can see, it stopped again. Here we have 10, 10 plus 10, 20, and 20 between 3. Now it's 6.6666. And we multiply it by 12, and it's 80. So now we have our bug fixed without needing to use a lot of debug.logs and things that are not that effective. In the next function, we have a very simple piece of code. As you can see, we just have a custom string and an integer number to count all the characters on it. And then we have a switch inside a for loop to increase that count. And then we debug both the values, the custom one and the actual string length. And as you can see, it's not giving us the same result. So to do that, we are also going to see another of the debugger features that are adding custom inspections. With normal variables, you can see them directly. But for example, if you want to see the current value of that piece of code, you can also watch it. So to do that, we just select it and click with the right mouse button. And then over here, we have this add to watches button. And if we click it, we are going to have it here, like all of the other variables. So now if we play the game, the debugger will stop there, and now we have the normal variables. And then if we enter in the for loop, as you can see, we have it here. Normally it will appear that the implicit evaluation is disabled. We are going to see how to enable right now, but if you press refresh, it will get the current value on that on that loop. So as you can see, it's a capital H. So here we are going to enter to the switch, and as you can see, it went to the default because it's a capital H, so it's not the same character. So to fix that, we just have to put a capital H, and we will have to do the same with the double B. And also, as you can see, well, we are going to look right after that. We are going to stop the debugger and enable it again for the next time. So now we are going to enable the inspection for that. So if you go to File, Settings, and then you go to, this will be like that. You have to go to Build, Execution and Deployment, and then here you have to go to Debugger and scroll down a little bit, and here you need to check this one, but also this one. So now we save it. So we play it again and stop on the same piece of code. Now, as you can see, if we enter into the for loop, now it will refresh automatically. Now it also will go inside this H, so it will add 1 to the count. Okay, so the next iteration, it will be automatically updated. So as you can see, you can add different custom inspections here, and for example, you can do whatever you want. It's like if you wrote a piece of code, so for example, you can do whatever you want. So for example, if you click edit, you can do, for example, custom count plus custom count. Hit enter, and as it's 1 right now, it will be 1 plus 1, 2. So that's not very useful right now, but it's just for you to see that you can add whatever custom inspection on the debugger. So as you can see, now we are on the E from Hello World, now on the first L, the second one, the O, and now we are on the space. So we don't have a case for the space, so it's not going to count one. So for example, what we can also do is put another breakpoint here and click resume, and it will just go to the next breakpoint. As you can see, custom count is 10 and the string length is 11. That's because we need to add the case for the space. So we can do it here, for example, and add 1 to the custom count variable and break. So now the bug is fixed, and we also saw how to add custom inspection variables and how to continue after, for example, a for loop. We just put a breakpoint there and pressed the resume button. In this function, we want to calculate the factorial number of 17. Factorial number is just multiplying the value of the number by each one of the previous numbers until 1. So this is the right value for 17 factorial, but we are getting a negative value. So we're going to debug that and see another tools from the debugger. So we just stop it there, and we are going to see the different iterations of the for loop. So we press F10, 1 multiplied by 2, and that keeps on. What we can do is just put a breakpoint here and just press the resume program or F5, and then it will just do all that's inside on the for loop, and we just want to see the value, so that's perfect for that. So we are going to see the values, multiply by 7, by 8, by 9, by 10, we keep on, 13, and now if you can see, when we multiply it by 14 in the next iteration, it will be a lower number. So now we know that there's something wrong since multiplying by 14. So if you didn't saw it, okay, I have the values here for that. So as you can see, when we multiply the previous number by 13, we get this value, and if we multiply this value by 14, we are getting a lower value. So okay, we are going to keep on with that. F5 again. Okay, as you can see, this is also a very similar value to the previous number, and when we multiply by 17, it gets a negative value. So we are going to add a custom inspection here, and as you can see, we are using an int variable. So we are going to look at the max value of a int variable. So as you can see, it's a much lower number than this one. So this is probably because of that, and we also getting a negative number because when we add 1 or any other number to the max value of an integer, it goes to the same number but negative. So now we know that the problem is with the int variable. That's because it only has 4 bits of space, so it doesn't have enough precision to store this number. So we can fix that by changing it with a double variable that it has 8 bits. And we can also show the max value of a double. If we put double max value, as you can see, it's that number and the comma displays by 308 zeros. So we definitely have enough space for the number with the double variable. Now we can also do another thing. If you right click on a breakpoint, you can add a condition to it, like if you were doing an if. So for example, we want to only stop on that breakpoint when the e value of the for loop it's greater than 12, because as we saw before, the problems were starting when we were multiplying by 13 or 14. So we can put it. We can do whatever we want. It's just like an if, so we can do ands. For example, we only want to stop it when it's greater than 12 but lower than 15. Okay, so we save it, and now we are going to finish the execution of that time, and we are going to do it again. Now our loop, it will only stop when it's higher than 12. So if we do that, we just go to here, it's stopped. We can do the first iteration, for example. So now it's 1, but now that we have that special breakpoint, if we press resume again, it will only stop when the e value is greater than 12. So now, as you can see, the number is already very different, and if we multiply it by 14 on the next iteration, it has nothing to do with the previous loop. So now we can multiply it with all the numbers. That's the last one, by 17. And now, as you can see, we have fixed the bug and we have the same value. In the last function of that script, we don't care too much about what's happening inside, but imagine that we need that this function is executed after another one. In this case, we need to be executed after test function 3. So here we don't have a real problem to fix that, but imagine that we have a very complex structure on our project and we don't actually know where this call is coming from and what's been happening before. So as you can see, here we have the call stack. Here we can see the previous function that were called before this one. So as you can see, we want this one to execute after test function 3, but it's executing after test function 2. And also, as you can see, it comes from the start. So we can double click on these different calls and it will take us to the to where the next function is being called. So as you can see, we can also see the last value of the variables on each of the functions. So this can be very useful to know which values we had before entering here. So as you can see, we can click on all the others. We also have the other values and factorial number of that one and different things. Here I have prepared another example with another monobehavior class that is basically spawning some enemies and adding them to a list. The enemy class have some private variables and I'm just assigning them some values on the constructor, and it also have another custom class with some more attributes that it's also not a monobehavior class. So as we are going to see, the debugger can see any variable and any piece of code, and it doesn't depend if it's a monobehavior or if it's a private or public attribute. So we are going to go to the for loop, and here we can see the current enemy with its variables, but we can also add an inspection for the enemies list. As you can see here, when I add the new enemy, it will appear here. So I'm going to put another breakpoint here and just generate a few more. And as you can see, the enemies list keep growing. So now I can see all the different values of the different enemies here. So I'm going to make this window a little bit bigger. So as you can see, I have all of them here, and I can also open the attributes class that, as you can see, it has the same attributes as well as the enemy class. So this is very useful because we don't need to put a lot of debug.log messages on all the classes. We don't care about if it's a private or a public member, or if it's a mono behavior or not. So I am just going to put another breakpoint here, remove this one, and this will complete the for loop. So as you can see, now I have all the enemies that I have generated here. So with this you can quickly see all the variables inside a list or inside some other classes or whatever you need. This has been a simple introduction to the debugger, but the tools that we saw are enough to start using it. So the next time that you need to fix a bug, try to use the debugger, because the best way to learn it is by using it. The hardest and most consuming step of fixing a bug is to spot where and why it's happening, and that's why we use it, because it makes faster and more effective our ability to find the bugs.